Okay, guys, so today I'm going to be working on homework day 8, problem number 1. I'm going to go ahead and work out pretty much all the problems in this assignment that I'm going to hold you responsible for. So here we go. Problem number 1. The problem reads, find the area of the base of a laptop which measures 11 inches by 14 inches and has the height of 2 inches. Again, I want you to focus on the word area. Okay, the word area only involves 2 dimensions. Okay, and area equals length times width in this particular case because the base is a rectangular figure. Okay, now I know it gives you 3 dimensions, but they use that to throw you off. Okay, they want to know just the bottom of the base of the particular laptop. In this case, it measures 11 by 14. Okay, so again, all you really had to do here was do 11 times 14, and that would have given you your answer. Okay, so notice how it says find the area of the base of a laptop. Okay, it doesn't ask you for the volume, so you just do length times width. Okay, so go ahead and figure that out real quickly. And that would be 154 inches squared. And that would be your answer for number 1. Okay, so go ahead and highlight it, circle it, so that you know that is your answer. Now, moving on to problem number 2. Problem number 2 asks, a jar has 5 red marbles and 10 blue ones. So, a jar contains 5 red, 10 blue. If you randomly pick a marble without replacing it and then selecting another, what is the fractional probability of getting 2 blue? Okay, so it's asking you to pick out twice. Okay, so you have 1 pick and you have 2 picks. Okay, you're gonna pick out a marble twice. Okay, now this particular probability problem is called the compound probability. Compound. Okay, compound probability. Okay, and the reason being is because you're gonna use 2 different probabilities, and you're gonna come up with 1 combined probability. Okay, so I'm trying to pick out 2. Yes.
Do you have Josiah Hawley?
Yes, he's here.
He needs to report to the front office at this time, please.
He's on his way.
Backpack ready?
Okay.
Thank you.
Now, like I said, you're gonna pick out 1. You're gonna pick out 2 blue ones. So it says. It says on the first one you're gonna get 2 blue. Okay. The second you're gonna get 2 blue. So on the first try, it says you're gonna get 2 blue out of a total of. I'm sorry. What's the probability of picking out a blue one? Here. Let me erase this. What's the probability of picking out a blue one? Here it would be 10 out of 15. Okay, but if you read the problem carefully, it says the second pick, you're not going to put anything back in there. Okay, so now your total is going to be 14 because you just took 1 out. So what's the probability of picking out another blue one? Well, you just took out 1, so here is 9. So it would be 9 out of 14. Okay, so the thing with compound probability is that you're going to multiply them to get 1 combined probability. Okay, and you're going to do that by multiplying straight across. So here would be 10 times 9 is 90. 15 times 14. Go ahead and solve that on your own real quick. What would be 15 times 14? And the answer would be 210. Now, that in itself is a combined compound probability. But just like we do with every other fraction, we can simplify this. Then from when we simplify, you can turn it into decimal, decimal into percent. So let's go ahead and do that real quick. We're going to simplify this by a number, and it should give me a result. Now, just because I've already done this before, I know that 30 is going to be the number that I'm going to use. Okay, because 30 goes into 93 times. 30 goes into 210 7 times. Okay, so the combined probability of picking out a blue one on the first try and then a blue one on the second try without replacing it is 3 out of 7. Okay, and I'm gonna turn that into decimal by dividing. Okay, so go ahead and do that real quick on your own. And I went ahead and got 0.42. Okay, if I wanted to turn that into into percent, I would go 1, 2, and my probability of getting that particular outcome is 42%. Okay, so that's how you solve for compound probability. So what I want you to notice though on this problem is that I went ahead and did my sample space. I want to have very clear what options I have, so that when I'm doing my diagram like this, it's a lot easier to refer back to it. Okay, so this is how you solve for compound probability. You multiply it. Okay, you get an answer, you simplify, turn that into decimal, decimal to percent. Okay, so that is how you solve number 2. Moving on to problem number 3. Okay, problem number 3 asks, a small rectangle has a width of 3 centimeters. A large rectangle has an area of 210 squared centimeters and a width of 15 centimeters. If the two rectangles are similar, what is the area of the small rectangle? So I have one small rectangle who has a width of 3 centimeters, and I have one large rectangle whose area is 210 centimeters squared, but also has the width of 15 centimeters. Okay, so here's my width on both. Now, this problem is tricky only because there's a step that you gotta do before you can solve for the missing length on the small rectangle, which is what the question is asking. Okay, so I know that times width gives me my area. So how can I work backwards to figure out this missing? Okay, you would divide 15 by 200 or into 210 and tell me what you get. And if you go ahead and if you did your division correctly, you're gonna find out that the answer is 14. So my length times width gives me an area of 210. Okay, and I know the missing length here, but the question is asking what is the missing length over here. Now it also told you that these two figures are similar, and because they're similar, I know that they're proportional. Okay, that a number times this gives me this answer, but at the same time that same number gives me gives me this times this. Okay, that same number needs to be happening both times. So here it's really easy. 3 times 5 gives me 15. So this number times 5 gives me 14. So how can I work backwards there? You go ahead and divide. How many times is 5 going to 14? And the answer was 2.8 centimeters. So that was my answer, 2.8 centimeters. Okay, but because I did tell you that we were going to solve this through a proportion, I'm going to show you a different way of how to get that answer, because sometimes these numbers are not going to be as pretty. Okay, but I need you to understand that with similarity, this side times this number gives me this side. Well, that same number needs to happen all throughout the relationship. Okay, so I'm going to solve it through a proportion. I'm going to say, let's pretend that that was still x. I'm going to say x is to 3, x is to 3, this side is to this side, as this side is to this side. Okay, because we know that they're proportional. I'm going to go ahead and do my heart method. So I'm going to end up with 15x. And then what's 3 times 14? 42. Okay, then you solve for x by dividing, and that's gonna turn into 1. Okay, so what is 42 divided by 15? And the answer is 2.8. So again, I ended up with the same answer, but I chose a different way to get there. And personally, I want you to understand how to do both of them. This is not really the shortcut, because you can always double check your work with this. So it's just two different ways of getting there. 3 times 5 is 15. 2.8 times 5 is 14. These two figures are similar, therefore they're proportional. Okay. Again, not a very hard problem if you lay it out like I did. Please draw the diagrams, guys, whenever they're giving you rectangle examples or circle examples. Just go ahead and draw the diagrams, and it'll make your problem much easier. Okay. So that's how you solve problem number 3.